Welcome to 100 Days of Python, the Python Code Along Challenge. I'm Bill Mosley, and if you want to find the entire listing of the 100 Days of Python, you can find it at my website, www.bmosley.com/hdp. Let's get started. All right, so in this video, we're going to continue our study of fractal designs using recursive functions, and I want to show you a relatively well-known fractal, and it's called a Koch Snowflake. And in this one, you can see that there's some embedded recursion here at multiple levels. And what this does, or the result of this, is that it draws a series of sides of the shape where each side has an embedded repetition of that shape. So let's just take a look. It's probably easier to look than it is to explain. But this is a Koch snowflake, and you can see as it starts to draw this that the tiniest level here of repetition actually mimics the next largest shape, which in turn mimics the largest shape. And this is what a Koch snowflake looks like. And if I want to, I can make adjustments to the max depth that I want it to go, and I could make it go one level deeper, which of course slows it down exponentially. And you can see it's got a even finer level of detail. I won't let that play all the way out because it would take quite a while to render that. But if I go one step less than the initial one, you can see here it provides less detail, but the recursive pattern still shows up. And you can see basically each line segment is bisected by this little triangle shape here. So if we started this out as a triangle, which is the top level of this, you can see that each side of the triangle has another triangle built into the side of it. And each side of every side of that triangle has another little triangle built into it, and so on. So if we go to a depth of 1, this is the shape we get. If we go to a depth of 2, each one of those sides then has a little triangle built into the middle of it. And then of course we go to the depth of 3, and once again we have an additional triangle built into the side of that. So that is an example of what fractal images do. They repeat a pattern at smaller intervals inside of each other. And for that, we use recursion, which of course is this idea of calling a function inside itself. So we're going to take a little bit of inspiration from this Koch snowflake, and we're going to build a similar type of fractal image, but one that uses a square base rather than a rectangular base. So that's where we're headed with this, and let's go ahead and get into it here. So we'll clean that off, and we'll start with from turtle, import all, and then we will create a screen object. S equals screen. And this, of course, will be used down here at the bottom. I'll say S main loop, and that'll just keep that window open when it's done drawing. That's the main purpose of that right now. So I'm going to say int max level equals 5. That is the maximum number of recursion levels that we're going to allow. And I'm going to set the pin size to 2, just to make it a little bit easier to see. Okay, next we're going to start out by creating our initial recursive function. And this will be the main area of recursion. It'll be the one responsible for drawing the shape. So I'm going to say draw side. And we'll give it an int size and an int level as parameters. Okay, pretty basic so far. So the first thing we're going to do is, for each time this runs, we are going to ask if int level is less than or equal to int max level. So initially we're going to check to see if we've reached a maximum level of recursion. And if we have not, we are going to be recursive here. So now on each side of this shape, we are going to divide it into 3 parts. And the first and third part of that shape, or that line, are going to be just the straight line of the box. And so it's just going to draw the straight line of that box and nothing more. But the middle part of that is where we are going to have a smaller box that takes up 1/3 of that side. So what we're going to do, first thing is we're going to take int size, and we are going to divide it by 3. So that this little shorthand says whatever int size is equal to, take that and divide it by 3, and then put that value back into that same variable. So that's a little shorthand for that there. And then we will move forward. Int size divided by 2. And that will get us just a little bit into the shape there. And then we're going to do our pop out. So we're going to go left 90. And then we are going to do our first recursive call. So we'll go draw side, and we're going to go int size, and we're going to say int level, comma, int level +1. Okay, so that, and then we're gonna make it right. So if you can imagine, if we're going horizontally left to right, we turn left 90 degrees, then we're going to be pointing north, and then we'll draw a side, and then we're going to turn right 90 degrees. So we're headed back to the east or to the right hand side. We'll draw another side, and then we'll turn right again 90 degrees and draw another side, and we're headed back down to our original line here, and then we will turn left and continue our side here, and we'll go forward, int size divided by 2. Okay, so that gives us our full shape with a recursion if we haven't reached that max level. And if we have reached the max level, which is the else condition here, then we just go forward and we go int size. Okay, so that is one side of the box. So now if we want to do this 4 times, we want to draw 4 sides to this recursive shape, we're going to create another function called drawBox. And we are going to give that int size and int level. And basically those are just there to pass those along to draw side. But this is sort of a shell function here. And inside this function, we're going to say for x in range, and we're going to go 4 because it's going to have 4 sides. And we're going to do 4 times. We are going to say draw side, and we're going to say int size, int level, and after we draw a side, we're going to turn right, and that's where we're going to draw the shape. Okay, so now to set us up for this, we are going to, well, before we do anything, let's test out draw side. So we say draw side, And if we say int size is, let's say 300, no, let's say 400, and we'll say level 1 to start. So we're just calling draw side. Let's see what happens if we do that. So we're going to run this, and okay, wow, we've got it moving super slow here. Let's go ahead and speed up that. Let's make it 9. That's not all the way fast, but it's much faster. Okay, so there is our turtle. Still kind of moving slow, but you can see it's drawing a single side here, so it's partway done. And you can see here that we've got our baseline here, and then it's got our pop-out shape, which is a square. And then from that shape, we've got a pop-out shape, which is a square. And from each side of that, we've got a pop-out shape, and we've got another pop-out shape inside that. So that gives us one side. So if we draw, I'm going to speed up the turtle all the way now. And if I say draw box, okay, let's run that. And this is as fast as that poor little turtle can go, but we'll let it run just a little bit. You can see it's doing the recursion. It's going to finish out this whole side, almost done with this side, and then it'll just go straight into the next side, and it's going to complete that whole square. So that is our new snowflake. I don't know, it's not a Koch Snowflake, but it's a square version of the Koch Snowflake. So let's tweak this just a little bit to have a little bit more fun. And the first thing I want to do before we draw the box is I want to teleport it. Teleport, there we go. Teleport, I'm going to go -200. That'll move it to the left a little bit. And we're going to go 200 up. And then I also want to increase the size here. So let's go, we can go, I think 750 here. And main loop doesn't have to be all the way down there by itself anymore. So we'll move that back up here. And this is our little, we can call it a Mosley snowflake maybe. I don't think I'm the originator of this idea, but it is interesting. And you can see now a little bit more of the detail that's in this. And another thing that's interesting is to be able to envision the levels of recursion a little bit. If we color each level of recursion a different color, you can kind of see where those levels of recursion exist. So let's make one more modification to this. And inside draw side, I'm going to create a list of colors. And we'll start with black, and then red, and then orange, and then I think I'm going to skip yellow because it doesn't show up very well. Green. Well, why don't we do this? White. And let's go BG color. Let's change the background color of the screen to black. Let's see if that works for us. It did. Excellent. Okay, so now we're going to show color on black background, which might look kind of cool. We'll go blue, and then finally purple. We probably won't use all of these, but just to be safe, we got a nice list of colors. And then we're going to change the color based on the level. So I'm going to say LI colors, and I'm inside that for the index. I'm going to give it int level -1. So it'll start out with white at level 1, and then I'll go to red, orange, green, and so on. And so I'm going to do that. And then I want to also, down here at the end, after it does the recursion, it needs to change back to the higher level of recursion. So I'm going to say color, and I'm going to say li colors, and I'm going to say int level, and I'm going to say -2 this time, because this is what's going to change it back to the right color after each level of recursion. So let's see how this works, and we'll see how it looks. Yeah, that looks pretty good. So here, if you look carefully, you can see we've got white, which is level 1, red, which is level 2, orange, which is level 3, right? And then green, and then blue is in there, and purple. So this is really showing us all of the levels of recursion that take place in this fractal image. So each level is now represented by a different color. And that looks kind of neat on the black background. What I want to do before I let this run too much further is I want to make it really big, and it'll go straight off the screen here. But I want to say, let's make it 2000, because I want to show you what it looks like to see those levels of recursion. And now we can see them really well. We can see all the colors all the way down, and obviously it's going off the screen here, but you can see level 1, 2, 3, green is 4, blue is 5, so there's that blue square, and you could kind of envision the square of each color, and then the purple is that last level of recursion there. So this is really, really cool to be able to see that level of detail. So I'm going to run it back down to 750 here, and I'll give it one last run. I'm going to pause this while it runs out, and then when it's done, I will show you the finished image. Okay, and here is the completed fractal image of the square snowflake, for lack of a better term. And so, I would encourage you to play around. Maybe you can figure out a way to use curved images or circle parts to replicate something like this. I think it is definitely possible, but it does take some playing around. And the important thing to remember is that with recursion and with fractal images, one of the important principles to remember is you want something that's a repeatable pattern. So if for it to be repeatable and recursive, it kind of has to end up back in line with where it was before. If you watched the video yesterday, one of the things we did, one of the tricks that we used to do that was to read the position and the heading of the turtle at certain points before we would draw the bunch of leaves and the flower, and then it would return back to that point. So you always want to be tracking, where is the turtle ending up when it finishes drawing a shape, and how does that relate to the bigger shape overall? And that's sort of what makes a fractal image work. And so it's kind of a fun mathematical puzzle. I hope you enjoy playing around with it, and we will see you next time. Thank you so much for watching this video and coding along with me. Once again, if you want to access the entire listing of 100 Days of Python, you can do it at my website, www.bmosley.com/HDP. You can also access my book, Introduction to Python Programming for Absolute Beginners, at my website, www.bmosley.com/book. Thanks again, and we'll see you around.